class, I'm Miss Colleen.
And I'm Miss Ashlynn.
And today we are going to be learning about Pythagoras. Before we begin, does anybody have any idea of who Pythagoras was?
Millie, thank you for raising your hand. No, it doesn't have anything to do with pythons, but that is a really good guess. I see where you would think that. So we're going to learn about who he is. He's actually a person. Who was Pythagoras? Pythagoras lived from 570 BC until 495 BC. That was 2,500 years ago. That was a long time ago. He was a mathematician and a philosopher. He was born in Samos, which was a Greek island, and he's known for his discovery of the Pythagorean theorem, which we're going to talk about today. He died in 495 BC due to unknown causes. What did he discover? Why are we even talking about him? He discovered the relationship of the sides of a right triangle. So we've been talking about right triangles, and we've been looking at their lengths of their sides. So he came up with the Pythagorean theorem, which helps us decide how long the length of one of the sides of a triangle is without knowing all of its side lengths. He found that the square of both of the shorter legs of a right triangle equal the square of the hypotenuse, which is the longest leg of the right triangle. The Pythagorean theorem is a squared plus b squared equals c squared.
So how can we use the Pythagorean theorem in class today? So in our math class, we can use story problems to apply the Pythagorean theorem to real-life situations. So we could use the Pythagorean theorem to find missing sides of a right triangle. We could also use a story problem that involves the Pythagorean theorem to find the distance between places, the length of shadows, or even the height of buildings. So we can use it for a lot of different things. So what is a right triangle and why is it important? We've been talking a lot about right triangles lately in our class, so you guys should know what most of these labels are. So what are some things that a right triangle must have? Yes, Jameson. Correct. A right triangle must always have a 90-degree angle. That's what makes it a right triangle. Good job. What's another thing that a right triangle must have? Yes, Allie. Correct, a hypotenuse. A hypotenuse is the longest leg of a right triangle. It is directly across from the 90-degree angle of the right triangle, and it is labeled as side C. Good job. What are two other things that a right triangle must have? Yes, Harper. Correct, it must have two shorter sides, and these sides are labeled side A and side B. And we need all three sides of the triangle to use the Pythagorean theorem, which again is a squared plus b squared equals c squared. So now we want you guys to get in your math notebooks and give this problem a try. So here we have our right triangle. It has its 90-degree angle, and two of the sides are labeled. And then we have side A. So I would like you to discover what side A equals. Notice that our triangle's measurements are in inches, so keep that in mind when you put your answer down. So we'll give you a few minutes and we'll come back and talk about it. All right, is everybody about ready? Sounds good. All right, so here on my paper, I have drawn my triangle. So I have my 90-degree angle here in the corner. I have my side B, which is 4 inches, my hypotenuse, which is 5 inches, and I am solving for side A. So we know a squared plus b squared equals c squared. Let me hold this up for you guys to see. We know this is true because it's the Pythagorean theorem. So let's plug in our values into our equation. So we still don't know what a is because that's what we're solving for. So we are going to leave the a squared completely alone. But we know b is equal to 4 inches. So we're going to go plus 4 squared because 4 is the value of B. And we know our hypotenuse, which is C, is equal to 5 inches. So we're going to plug that value in for our C. So A squared plus 4 squared equals 5 squared. And I know we've just started talking about squaring numbers, but when you see the square up in the corner, it just means you take that number times itself. So we're going to take 4 times 4 and 5 times 5. So who can tell me what 4 times 4 is? Yes, Malachi. Good job, it is 16. So we have A squared plus 16, and then who could tell me what 5 times 5 is? Joshua. 25. You are correct. So 25. So now we have A squared plus 16 equals 25. But we need to get this A all by itself. So how could we potentially do that? How could we get this A on this side of the equation by itself? Yes, Lene. That's right. We'll subtract the 16 from each side. So now we have A squared, which equals 25 minus 16. And who can tell me what 25 minus 16 is? McKinley. Correct. It is 9. Good job. All right. So do I have the A on its own side of the equation? Yes. Does it equal something? Yes. But we still have a problem. It still has a squared. We want just the value of A by itself. So how could we do that? How could we go about getting A completely by itself? So when we put the little 2 up in the corner, that's called squaring a number. But what's the opposite of that called? We've talked about it a few times. Who remembers what the opposite of a square, or taking a square of a number is called? Keenan. Correct. It's a square root. So we are going to take the square root of 9. And when you take the square root of a number, you're trying to see if there are any 2 numbers that multiply together to equal this number. But you want those numbers to be the same. So how could we go about factoring out a 9? So we could have 9 times 1 or 1 times 9. It's the same thing. It's just the reciprocal. What other numbers go into 9? Is it an even number? Nope, it's not. So 2 doesn't go into 9. How about 3? What do we know about 3? Yes, Joshua, what do you know about 3? Oh, that's a good point. He says if you take 3 plus 3 plus 3, you would get 9. That's a good point. So if I took 3 and multiplied it by 3, would that give me 9? Do you think so? I see a lot of head nods. I agree. 3 times 3 is 9. So 3 times 3 equals 9. Are they the same number? Yes. So that would be the square root of 9. So A would equal 3. But what am I forgetting with my answer? What is our measurement in this equation? Inches, right. So A equals 3 inches, and then you always circle your answer so it's easier to find. So good job, guys. That was a great lesson on who Pythagoras was and how we can use the Pythagorean theorem.
Yes, good job.
Good job, guys.